Hi everybody. If you're anything like me, it's driving you crazy that you just have the distance formula and you have the circle formula. They look really similar, but you don't understand why they're the same. So I really want to give you some explanation for where the distance formula comes from and where the circle formula comes from. So first we'll just talk about how the distance formula inspires the circle formula, and then maybe in another video I'll tell you where the distance formula itself comes from. So let's see how they're related. So first of all, let's write the distance formula. So if I want the distance between the points x1, x2, here I actually want to record this. So we want to see how they're related. To find the distance between the points x1 and x2, and y1, and the other point being x2, y2, then the formula that you've seen is it's going to be the square root of the difference in the x values. So x2 minus x1 squared plus y2 minus y1 squared. So that gives us the distance between 2 points. So let's say here is my x1, y1, and here's my x2, y2. Then this formula tells us the distance between them, the length of the line segment that connects them. So that's the distance formula. Now the equation of a circle looks oddly similar. So a circle with center h, k and radius r looks like r squared equals minus h squared plus y minus k squared. So it looks a lot like the distance formula. The distance formula has a square root, but if I just squared both sides, then the square root could go away, and that might explain this r squared. And the distance formula has these different labels, has x2, x1, y2, y1. When we do the distance formula, we're plugging in numbers for all of these values. All these 4 values, we plug in numbers. When we do the equation of a circle, we're only plugging in numbers for h and k. But that makes sense because an equation, and for r, but an equation should have x's and y's in it. So it sort of makes sense that that's the way we do it. So let's look at an example to see why these are so similar. So I want to describe a circle with radius 4 and center at -1, 2. And I want to describe that a point x, y lies on this circle. So let's draw this circle. -1, I'm going to make each of the hashes on the sides count as 1. 2, that's the center of my circle, and the radius is 4, so 1, 2, 3, 4, that's the length of 4, that will give me another point, so my circle looks something like this. So any point on the circle is 4 away from the center, -1, 2. So what does that mean? If I pick a random point x, y, this says the distance between x, y, and -1, 2 is 4. Okay, let's write this as a mathematical sentence. So the distance between x, y, and -1, 2 is going to equal 4. But now if I use distance formula to write the left-hand side, I get that the square root of x minus -1 squared plus y minus 2 squared equals 4. Now, this is just rewriting that mathematical sentence. This is the math, this is the English. But now if I go one more step and square both sides of this, then I get x minus negative 1 squared plus y minus 2 squared equals 16. Or maybe I should write it as 4 squared. This is my h, this is my k, and this is my r. So the equation of a circle is really just a restatement of the distance formula where I leave x and y in because I'm trying to describe all the points on the circle, not just a single point that's 4 away. I'm trying to describe all possible points that are 4 away. So I hope that this clarifies things a little bit in terms of the equation of a circle. If you liked this, then let's keep on going and talk about where the distance formula comes from. So the distance formula is derived from the Pythagorean theorem. You'll remember that if I have a right triangle, then if I have a side A, B, and C, the Pythagorean theorem says that a squared plus b squared equals c squared. So we're going to be using this to come up with the distance formula. Oops, sorry, you couldn't see any of that. The distance formula is coming from the Pythagorean theorem for a triangle which has a right angle, a squared plus b squared equals c squared, the hypotenuse. So let's say I want to come up with the distance between 2 points. Maybe I have, so that's the origin. Let's go to 4, 0, and, well, that point's too easy. Let's do another one. Let's do 4, 2, and 4, 5, 6, 7, 8, 9, and 9, 4. And I want the distance d. So I can get this using the Pythagorean theorem as follows. This d, so using the Pythagorean theorem, d squared is going to be a squared plus b squared. So d is going to be the square root of a squared plus b squared. So how do I figure out a? It's this horizontal length, and it's going to turn out that a is just 1, 2, 3, 4, 5. It's the length of that side. So I can get that mathematically by just subtracting the x coordinates. So a equals 9 minus 4, which equals 5. B is just the difference in the y coordinates. So b is 4 minus 2, which equals 2. So rewriting this, I'd have d equals the square root of 9 minus 4 squared, that's the a squared, plus 4 minus 2 squared, that's the b squared. And this is exactly what I would get by using the distance formula, which says d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I could continue calculating this out. 9 minus 4 is 5 squared, and 4 minus 2 is 2 squared. So this is going to be d is the square root of 25 plus 4, which is the square root of 29. So that's where the distance formula comes from. The horizontal side is the difference in the x values. The vertical side of the triangle is the difference in the y values. So I plug into Pythagorean theorem to find the length of this hypotenuse. And that's really all there is to it. That's how you derive the formula for the distance. I hope that this clarified things. I definitely like to see the why behind an equation. So good luck with the web work, and let me know if you'd like to see some more proofs like this.